How mirrors are made in factory. Mirrors are manufactured in factories through a multi-step process. It begins with the preparation of a smooth glass substrate, which is meticulously cleaned to remove impurities. A thin reflective coating, often composed of materials like aluminum or silver, is then applied to the substrate using techniques such as vacuum deposition. Following this, a protective layer is added for durability. The coated substrate undergoes drying and curing to solidify the layers. Mirrors are then cut and shaped to desired specifications before undergoing the final inspection for quality assurance. In the case of safety mirrors, a backing material is applied. This meticulous process ensures the production of high-quality mirrors ready for distribution. Substrate preparation. Substrate preparation is a crucial initial step in the manufacturing of mirrors, ensuring the foundation for optimal reflective properties. Typically, glass serves as the primary substrate, chosen for its smooth surface and transparency. Prior to coating application, the glass undergoes a meticulous cleaning process to eliminate any impurities or contaminants that could compromise the mirror's quality. This thorough cleansing is imperative as even minor particles can impact the adherence of the reflective coating. The substrate is meticulously inspected to meet stringent standards, and any imperfections are addressed before proceeding. Once the glass substrate is pristine, it is ready to receive the reflective coating that will transform it into a mirror, effectively capturing and reflecting light. The care taken during substrate preparation lays the groundwork for the mirror's functionality and clarity, playing a pivotal role in the overall manufacturing process. Coating application. The coating application phase in mirror manufacturing is a pivotal step that imbues the substrate with reflective properties, transforming it into a functional mirror. Typically composed of materials such as aluminum or silver, the reflective coating is applied using advanced techniques like vacuum deposition or sputtering. These methods ensure the creation of a thin, even layer of reflective material on the prepared substrate. The substrate, having undergone meticulous cleaning during the earlier stage of preparation, is now ready to receive this reflective layer. The coating application process demands precision to achieve uniform coverage, which is vital for the mirror's optical quality. Following the application, the coated substrate may undergo additional steps, such as the application of a protective layer to prevent damage or corrosion. This phase not only defines the mirror's reflective capabilities but also sets the stage for subsequent processes, contributing significantly to the mirror's overall performance and longevity. Protective layer application. After the reflective coating is applied to the substrate in mirror production, a protective layer is strategically added to enhance durability and longevity. This protective coating serves as a shield against potential damage, corrosion, and environmental factors that could compromise the mirror's reflective properties over time. It acts as a barrier, ensuring the integrity of the reflective surface and maintaining the mirror's optical clarity. The type of protective layer applied depends on the intended use and environmental conditions the mirror will face. This crucial step in the manufacturing process not only safeguards the mirror but also contributes to its overall quality and resilience. Drying and curing. Following the application of the reflective coating and any additional protective layers in mirror manufacturing, the substrate enters the crucial phase of drying and curing. This step is essential to solidify the coatings and ensure their proper adhesion to the substrate. Drying typically involves allowing the coated substrate to air dry or using controlled environments like ovens or curing chambers to expedite the process. The drying phase removes solvent residues and facilitates the initial hardening of the coatings. Curing, on the other hand, is a more controlled and extended process aimed at achieving the desired chemical and physical properties of the coatings. This may involve exposing the coated substrate to specific temperatures, humidity levels, or even ultraviolet (UV) light, depending on the composition of the coatings. Curing enhances the durability and stability of the reflective and protective layers, contributing to the mirror's overall performance and resistance to environmental factors. The meticulous management of drying and curing conditions is critical to ensure the coating's uniformity, adhesion, and long-term effectiveness in providing a clear and reflective surface for the finished mirror. Quality control. Quality control is a pivotal stage in mirror manufacturing where stringent checks are conducted to ensure the mirror meets exacting standards. During this phase, mirrors undergo comprehensive inspections to identify and rectify any defects, ensuring optimal optical clarity. Quality control encompasses scrutinizing the reflective coating for uniformity, examining the substrate for imperfections, and verifying that protective layers are flawlessly applied. Mirrors that pass these meticulous checks are deemed fit for distribution, while those falling short of the specified criteria undergo corrective measures. This rigorous quality control process is integral to delivering mirrors that meet high industry standards and customer expectations. Cutting and shaping. The cutting and shaping phase in mirror manufacturing is a crucial step that transforms large coated sheets into the final desired mirror forms. After the mirrors undergo coating, drying, and curing processes, they are ready to be shaped according to specific specifications. Precision cutting equipment is employed to trim the mirrors into the desired size and shape, whether it be rectangular, square, or custom configurations. This step is essential for tailoring mirrors to various applications, from standard household mirrors to specialized mirrors for specific industries. Additionally, mirrors may be shaped into concave or convex forms to serve specific optical purposes. The cutting and shaping process demands accuracy to meet design requirements while minimizing waste. Computer-aided cutting technologies may be utilized for intricate designs, ensuring consistency and efficiency in the production line. This phase not only defines the physical appearance of the mirror, but also plays a significant role in optimizing its functionality for diverse applications. Backing application for safety mirrors. In the production of safety mirrors, a key step involves the application of a backing material. This additional layer serves as a safety measure to prevent shards from scattering in the event of mirror breakage. The backing material is carefully applied to the rear surface of the mirror, reinforcing its structural integrity. This feature is particularly important in environments where safety is a priority, such as public spaces, retail settings, or industrial facilities. The backing application enhances the safety profile of the mirror, making it a valuable solution for areas where the risk of breakage is a concern. Final inspection. The final inspection stage in mirror manufacturing is a critical checkpoint where mirrors undergo thorough scrutiny before reaching the market. This comprehensive evaluation includes a meticulous review of the mirror's overall quality, checking for defects, scratches, or imperfections that may have occurred during earlier stages. The reflective coating is scrutinized for evenness, and the dimensions are verified against specifications. Mirrors that pass this rigorous final inspection are deemed ready for distribution, while any mirrors with identified issues undergo necessary corrections or are rejected to maintain the highest standards of quality. This conclusive step ensures that the mirrors leaving the manufacturing facility meet the prescribed criteria, providing customers with products that excel in both functionality and aesthetic appeal. Conclusion: mirrors are crafted in factories through a meticulous process involving substrate preparation, reflective coating application, protective layering, drying, cutting, and a final inspection. This systematic approach ensures the production of high-quality mirrors, meeting both aesthetic and functional standards and ready for distribution in various applications. Thanks for watching. I hope you like it. Subscribe to the channel and hit the bell icon.